Okay folks, we're going to finish off our 6-week whirlwind triangle adventure with the cosine rule and a few little exam questions. Let's go! So let's just define this straight out of the bat. I think you already know all of the definitions and nomenclature at this point. Cosine rule is as follows. If we want to find a side of a shape, then we can use this rule. A squared is b squared plus c squared minus 2bc cos a. And remember that when we're labeling our triangles, when we talk about side A and angle A, they're always opposite each other. So we could have a triangle that we labeled something like that. Sides in lowercase, angles in uppercase. I'm going to go straight into an example here. So let's do that. First thing we want to do is we want to label our sides. So let's do that. The side that we're trying to find is normally the thing you want to make A. So we'll call this A here. Let's just write it slightly further away, and obviously that means this is angle A. This means these can be side B and C in any order you like, doesn't really make a difference, we're doing the same thing with them, but they're the other two sides. So yeah, that should be fine, and let's use the formula. So A squared, which is x in this case, is equal to B squared, which is 5, C squared, minus, and if we say 2bc cos A, that's 2 times B times C times cos 60 in this case. Now if you type all that in, you'll get yourself 109 coming out. But we don't want x squared, we want x. So let's square root that, and we'll get that the length of that missing side is 10.44 centimeters. So that's it. Cosine rule, use the sides. Let's have a look at some other alternatives. So here's two other examples of the same sort of thing. I'd like you to give them a go first, and we'll come back in 3, 2, 1. Okay, let's label up our sides. So fortunately the side we're trying to find is already called A. So that's angle A, that's B, and that's C. So we're going to say that A squared is 7 squared plus 11 squared minus 2 times 7 times 11 times cos 62. And we'll get there, that will give us A squared is 97.7. So we square root that, and we'll get that the length of A is 9.88. Same thing for the second one. I would try and get in the habit of like scribbling out whatever letter they give things and say the side you're trying to find is always A, because then the formula will make more sense. If you call that B, then you have to relabel everything and the formula doesn't work anymore. So the side we're trying to find is A, that's our B, that's our C, that's our angle A. So A squared is equal to 12.5 squared this time, plus 9.5 squared, minus 2 times 9.5 times 12.5 times cos 46. So that mouthful gives us 81.5 as our answer. We'll square root that and we'll get that A is this time 9.03. Those are both centimeters, aren't they? Yeah. Yeah, hopefully you got those right, and if you can do that, you can apply the cosine rule to find sides. Let's look at angles. So this next bit is not something you'd be required to do, but you kind of got two choices. You can either learn two different versions of the same formula, or you can learn one of them and learn how to rearrange it to the other type. I'm going to show you the rearrangement. It's kind of up to you whether you want to learn this or whether you just want to remember both. So if I was trying to rearrange this, I want to make cos A the subject. I'm going to first subtract the b squared and the c squared. So we're going to end up with a squared minus b squared minus c squared on this side, and on the right hand side we've still got minus 2bc cos A. So I subtracted them. Next thing I want to do if I want to get cos A on its own is I'm going to divide, and I'm going to divide by this minus 2bc. So I'll end up with a squared minus b squared minus c squared all over minus 2bc, and that will give me cos A. So yeah, that is our rearrangement. So let's actually look at using this on a question where we have to find an angle. It says here that we're trying to find angle BAC. Remember, you're always looking for the middle letter there, so we want to find, let's label this with a theta. And let's apply our cosine rule. So we want to label stuff up first, don't we? So the angle that we're trying to find, we'll call that A. The side opposite it is obviously A as well. And then the other two sides, B and C, doesn't matter what you call them. And we'll end up with this. We'll end up with cos A is equal to, and then a fraction, 12 squared minus 15 squared minus 10.5 squared on the top, and minus 2 times 15 times 10.5 on the base. And if you work out the top and the bottom separately, which I would recommend doing, it'll mean you get a few more method marks if you mess up somewhere, you'll get that this is equal to 0.607. But we don't want to find what cos A is equal to. We want to find what the angle is. How do we get rid of cos in this situation? Well, we've done it with SOHCAHTOA, we've done it with the sine rule. We use shift cos or inverse cos. So we are going to do cos minus 1 of our 0.607. And we're going to get here 52.6 degrees. Seems straightforward enough. Let's have another couple of examples. Would very much like you to pause the video at this stage and have a go yourself, but I'm going to assume you've done that in 3, 2, 1. Okay, so always label the angle you're trying to find as A. That doesn't mean anything on the left-hand side one, but the other one we do need to relabel it. We've got side A over here, and then side B and C, doesn't matter which order we have them. So side A and B and C. And then we want to put those numbers into the formula. So cos A is equal to 8 squared minus 6 squared minus 12 squared all over minus 2 times 6 times 12. And on this other one, cos A is equal to 13 squared minus 9.1 squared minus 10.5 squared all over minus 2 times 9.1 times 10.5. Okay, so if we plug those in the calculator, then we'll get that cos A is 0.806 roughly on the first one, and we'll get just 0.126 for cos A on the second one. What do we need to do to find the angle? Of course, we need to use shift cos. So we'll do that on the first one. And we'll end up with an angle of 36.3 degrees. An excellent answer. And on the second one, we'll end up with a much bigger 82.8 degrees. Not squared, degrees. Yeah, hopefully that makes sense as well. So what could we do with this to make it awkward? Well, the problem with like the sine rule and the cosine rule is not necessarily using them, although I guess there's some finesse to it. Part of the problem is remembering them because none of these formulas are given to you in the actual exam. But the main problem is knowing which one to use and in which scenario. So I thought it was just worth going through, now we've seen all of the trig possibilities, what you'd need to use. So first off, you need to ask yourself, is my triangle right angled or not? If it is right angled, then we can use Pythagoras or we can use SOHCAHTOA. It should be pretty obvious which one you're after. It's a Pythagoras question if it's about the 3 sides of the triangle, and it's a SOHCAHTOA question if it's about 2 sides and 1 angle. I feel like those are okay to recognize. It's this sine cosine rule that I want to specialize on. We use sine and cosine rule on a triangle that isn't right angled, and we want to use the sine rule if there are 2 sides and 2 angles that are labeled. What do I mean by that? So this is a perfect example of the sine rule because we have got 2 sides labeled. We've got 41 and we've got 28, and we've got 2 angles labeled, 92 and the one we're trying to find. So I do include like the one that you don't know yet. So that's a perfect example of the sine rule. Are there any other examples of the sine rule there you can see? Yeah, there's a couple, isn't there? So this one has 2 sides and 2 angles, so this would be a sine rule, and it'd be a sine rule where we're trying to find the angle. And is there another one? Yeah, the one directly underneath it as well. 2 angles, 2 sides. We want to use the sine rule there. What about the other ones? Well, there is one right angle triangle, which is here at the bottom. We've got 4, 5 and x. We've got 3 sides labelled. So that would be, according to our little list, that would be a Pythagoras question if we wanted to solve that. And then what's left? Well, none of the other ones are right angled, so we can ignore that. This one here has 1, 2, 3 sides and an angle. So that's a cosine rule question. 1, 2, 3, and an angle, cosine. 1, 2, 3, and an angle, cosine. So yeah, before you start one of these trig questions, if it's not obvious what you need to do, have a count of the number of sides and angles that are labelled and try and follow that idea. So let's jump straight in with an interesting question that uses more than one of these rules at once. It's probably worth reminding you of everything that we should know at this stage. Obviously there's SOHCAHTOA and Pythagoras, but this doesn't look like right angle territory. So we're choosing between a half AB sine C for an area, or we might want to use the sine rule, and there's two versions of that. A over sine A is B over sine B, or sine B over B is sine A over A. And that's if we want to find angles. That's if we want to find sides. Or we could be using the cosine rule, and there's two versions of that now. So our sides one is A squared, it's B squared plus C squared minus 2BC cos A. And the angles version of that was A squared minus B squared minus C squared over minus 2BC is equal to cos A. So we have got there quite a variety of different possibilities that can be used. And you don't get told these in the exam, you've got to go in knowing them. So this is a good question to look at. So we're told that we want to find the length of AC. That's this length here, side X. Now, which triangle are we going to use? Well, we could use the bottom triangle. We have two sides for that and an angle, but that's not enough for anything. We want two sides, two angles for sine rule, or we want three sides, one angle for cosine rule. So we're actually going to have to use the top triangle because we have 1, 2, 3 of the sides and we have an angle. We're finding a side, so we're going to use the A squared equals B squared plus C squared, etc. And our A is going to be this missing side, and our B and our C are going to be the 12 and the 9, and our angle A is going to be the 93. So let's do that. We will say A squared, so that's X squared, is equal to 12 squared plus 9 squared minus 2 times 12 times 9 times cos 93. If you type that in, you'll get yourself to 236.3, but we want to square root that, obviously, because that's x squared, so it's going to give us 15.37 centimeters, because the units are centimeters. Hey, that's part A. Part B says we want to find the length of CD, so let's get rid of some of our labeling here. We want to find this length here, we'll call it y, and we do now know that this is 15.37. So we can use the bottom triangle because we've got a side, a side, a side, and an angle. That's cosine rule again. So let's do that. Once again, we've got our angle A opposite our side A, so 68 and y are opposite each other, and B and C are 7 and 15.37. So we'll go straight in and we'll say, so y squared is 7 squared plus 15.37 squared minus 2 times 7 times 15.37 times cos 68. And if we type that in, we should get that y squared is 204.63 or thereabouts. So we square root that and we'll get that y is 14.30, I guess. Great, okay, so that's part B done. But we still have part C, and part C says we want to find the size of angle ADC. So let's get rid of our stuff again. We can now write in that this length is 15.37, that this length is 14.3, and ADC is the angle at D, isn't it? It's that one there. So we'll call that theta. Now, you've got a choice here, because if we look at this bottom triangle, we have got 1, 2 angles, and we have got 1, 2, 3 sides. So we could use the cosine rule again and ignore one of the angles, or we could use the sine rule and ignore one of the sides. In the interests of being varied, I suppose, let's use the sine rule. Let's just pretend we're going to ignore this 14.3 for now. We'll stick with 2 sides and 2 angles. In fact, that's probably not the right one to choose because we want angles opposite sides, don't we? So we need the 68 and the 14.3. We want the 15.37 because it's opposite the angle. So yeah, so it's the 7 that we're going to ignore for this third part. So for C, We use a sine rule, and we use the version where we want to find angles. So we'll have sine theta over 15.37 is sine 68 over 14.3. And then remember, to do this, we want to multiply. So we're going to need to do 14.3 times sine 68 over 15.37, which is going to give us 0.863 dot dot dot. And so if we want to get the angle, we need to go to the -1 here, which will give us an angle of 59.6 degrees. So yeah, you can see there that you kind of use one answer to get the next answer, to get the next answer. And at each phase you're thinking, do I have two sides and two angles? Do I have three sides and one angle? Do I want to find a side? Do I want to find an angle? What's my next move here? So I wanted to look at one last question here. This gives us an area of a triangle and tells us to work out its perimeter. It's probably worth just writing down everything that we should know at the top here. This is not right angled, so it's going to be one of these three. So we've got half AB sine C for area. The sine rule, we've got A over sine A is B over sine B, or we can have, the alternative is sine A over A equals sine B over B. And then the cosine rule, the two versions we've got are A squared is B squared plus C squared minus 2BC cos A, or A squared minus B squared minus C squared over minus 2BC is cos A. So yeah, just remember that you have to go into the exam with all of these 5 formula somewhere in your head. Okay, so it mentions the area of the triangle. We're clearly going to have to use the area formula, so let's start with that. We'll say that area is a half AB sine C. We want to label this up, so C is always the angle that we're after, and A and B are the two sides in between it. So this is going to be our A and our B, and then this is going to have to be our angle C that we find. So let's plug in what we know. We know the area is 10, so it's equal to a half times 3.2 times 8.4 times sine C. And we can obviously divide 10 by that half times 3.2 times 8.4 to just get sine C on its own. If we plug that in, we'll get 0.744, and obviously it's sine, we want the actual angle, so we're going to have to use shift sign on that, and we'll get that missing angle is 48.1 degrees. Now that is definitely not answering the question. We have not found the perimeter of the triangle. We haven't even found a missing side of the triangle yet, but it's the only thing we can do. We were given the area, we haven't got enough information, we didn't have enough information to use sine rule or cosine rule, so we had to just rearrange that and see what it gives us. And it gives us an angle, and that's okay. So if we want to find the perimeter of our triangle, we're going to need to know the length of AC. So let's call that fella X. Let's get rid of some of our labels. Now, what do we want to do here? We have got 1, 2, 3 sides, and we've got one angle. 3 sides, one angle, that's the cosine rule. If it was 2 sides, 2 angles, we'd be using sine. So to finish this off, we're going to use the cosine rule. We're going to need to label this up again, so I think the angle should always be your A, so we'll cross over that B. So this is our side A, this is our side B, this is our side C. Remember, B and C don't matter which order they go in, and it's a side of a shape that we're trying to find, so we're going to use this top right formula. So let's do that. I'm not going to write out the formula again, let's go straight into it. We want to find x squared is equal to b squared plus c squared, so 3.2 squared plus 8.4 squared minus 2bc, so 2 times 3.2 times 8.4 cos A, so times cos of 48.1. We have to be confident in our previous answer, obviously. Let's type that in, and we'll get that x squared rather is 44.9. We can square root that, and we can get overall that x is 6.7, almost exactly, centimeters. Okay, are we done? No, because we still need to find the perimeter of the triangle. So you do need that final step at the end where we add up the side lengths. So we've got our 3.2 plus our 8.4 plus our 6.7. It said give your answer to 3 significant figures, so let's see what this looks like. This is going to go to 11.6, 18.3, and yeah, that is 3 significant figures, so no rounding needed. We're in centimeters. Yeah, there we go. So if you're given a question and it's not immediately obvious what to do, count sides, count angles, and think what's the only thing I can do with the information in the question. Best of luck.